Hey everybody, welcome. Hopefully everyone's having a great weekend so far. We are going to be getting the axes assembled today. So this will be a big one. It really kind of get the printer moving along with this x-axis built. I had to order a bunch of parts for this to work, so it'll be nice to see this on. And essentially, once the X is done, we got to put the Z on, and we're pretty much ready to start printing. So getting very excited to see this print. I've printed out a lot of different parts, trying to get together all the little things that I need, like fans and spacers and washers and all that kind of stuff. So I've been just like pre-assembling stuff and making sure things are working and stuff like that. I was hoping we could run belts today, but I'm missing some idlers and some spacers, so gotta wait for that. Hey, welcome. So off stream, I did get my mellow carbon tube. So this is a Voron 250 size carbon tube, and I did install my MGN 9H rail. So I am going with MGN 9 on X. The default for EVA is MGN 12, but there are mods on printables to use MGN 9. I'm not going direct drive, so I don't need an MGN 12 rail. So all I've done is I've just pre-installed my rail onto this mellow carbon fiber tube. So very straightforward, very lightweight. That's what I'm going for. So and then I've printed out all my carriages here. So I modified these bottom carriages so that they can actually work with the mellow carbon fiber tube. I will put these on printables, of course, but this is not the standard build. I am doing a few little mods to the printer to kind of make it my own. Normally you'd be using a 2020 extrusion for this. So we are going to go ahead and start mounting up the bottom carriages here. The angled part goes to the back of the printer, so we're going to bolt it on here. We'll bolt the other one on, and then we're going to actually put the carbon tube in place and make sure that it's all nice and level and working well. So first, let's mount up our Y carriages here. And I got to get my Allens. All right, so as I said, we're going to mount these up. I'm not going to tighten these yet. I do want to slide the x-axis forward, or I should say the y-axis forward, so that I can make sure that everything's trammed nicely and I lock everything in when it's up against something that's flat. Hey Pixel, welcome. So I am leaving these like just ever so slightly loose, so there is a little bit of play in them, so that we can make sure we tram up our X as good as we possibly can. So I'm just very loosely putting these M3x6 bolts in. That's all bolted on. We'll get the other side again. The other side has tabs for the mellow carbon tube that we are using in this particular build. Again, finger tight so that we can move them around. Make sure we can tram up that X as good as possible. Yep, the AT4 is all bolted up. Try to get the camera up a little bit higher so maybe you can see a bit better here. See if I can increase the height of this thing a bit. So it's a bit better for you to see maybe. I just ordered it from AliExpress. It's just a Voron 250 size carbon tube. So slide that into place just like that. So of course the tube doesn't have anything to hold the M5 nuts, so you do have to print out some adapter pieces. Basically they're just a rectangle, and there are M5 lock nuts inside here. This is holding M5 lock nuts in place so that I can bolt this. And those are on printables. I found one that I liked on printables. I'll probably put links to the parts that I used on the printables page. And so basically what we're going to do here is I'll grab my M5. And we're going to install these M5 bolts. Again, we are not tightening these. We are just going to install them so that everything starts to get aligned, and then we will tighten everything down once we can line everything up properly how we like. So we got our M5s installed on the back there. We'll pop two in the front. Again, these are just going into some M5 lock nuts that are held in place with some printed parts inside the carbon tube. Alright, so that's all mounted up. Of course it's running really smooth right now. No problem whatsoever. So what I'm going to do is I'm going to push this all the way to the front. I'm going to hold it forward, and I'm going to lock in my carriages. So we're going to tighten everything down so that my carriages are flat as possible and the X is nice and even. We have our right carriage as much forward as it can go, and our left carriage as much forward as it can go, so that we know that the X axis is nice and straight. So again, we're just gonna, and I missed a bolt over there, but that's okay. Again, runs perfectly smooth. I just got to put in one more bolt at the back here, but that's okay. Very straightforward build here. So we can see both of our carriages they touch at the same time, meaning the axis is not out of skew. Runs nice and smooth. So what I'm going to do is I'm also going to start tightening my M5 bolts here on the back and the front. And these are going into lock nuts. So one, they stay very tight. We don't have to worry about them coming apart when we're printing or coming loose. And we'll go to the back here and we will tighten them from the front. So we're going to we also are using M3 lock nuts on the linear rail too. So there are slots on the bottom of this tube, so we can put M3 lock nuts. So this is still moving really, really smooth. Not really any issues with that. We're going to just make sure everything is nice and tight. So not too bad. There's a little bit more resistance, but there's no binding. So we can decide to potentially loosen up a rail if we want to. However, I don't think it's so much that versus these carriages. But on the front, carbon fiber beam. Yeah, I had to modify the bottom plate so that I can, because the carbon beam won't work with EVA linear rail on the top, so you got to rotate it. So I had to make adjustments to the bottom plates. Oh, I grease it all up like crazy. It's not binding at all. It's perfectly smooth. But yeah, they are very, very greased up. But it's more so I can see one of my linear rails is still not like as flat as I would want it. This side is good, but this side is like, it's kind of screwy as far as its flatness, I guess. So what I want to do is I'm going to loosen this one here. I want to try to get it flatter because it's kind of, I don't know if these cheap Amazon rails are the issue or the cheap Amazon 2020 are the issue, but these MGN9s do not want to sit nice in my they don't want to sit flat, especially the one on this side. This side looks fine. It looks pretty flat. This side is angled down a little bit. Very rarely mentioned rails compatible with MGN. Suppose these differ better and they called SGR rails. Can't say I've heard of SGR rails myself. Okay, so I think what I'll try to do here is just angle this up a bit. That's better. And again, these are like dirty, cheap Amazon rails. They're not they're not high quality rails in the slightest. I'm building this thing quickly as I can to make sure that I can get a video out get the printables page out and stuff like that. I highly recommend using the rails on the bill of materials, not random Amazon garbage. So these probably don't sound that great because they're not that great. But I think what I'm going to do is I'm going to loosen up one side of this. I'm going to keep one side as my actual parallel side. And I'm just going to loosen this rail up a little bit to see if I can't get it even better. Again, even though I'm using really cheap, junky parts, I want this to be as good as I possibly can get it. So I'm just adjusting just one side ever so slightly. We're keeping one side parallel so that we make sure this is nice and parallel. I'm just going ahead and I'm locking this in place as I move the x-axis to make sure that it's straight. So that feels better to me. Again, we're just making sure that we get this as precise as we possibly can with the tools that we have and with the parts that we have. Okay, so that runs nice and good, nice and decent. Hey, welcome. So there's no like hard spot or anything like that. It's perfectly smooth in the entire motion. But yeah, I can definitely tell. Where is my calipers? I can definitely tell that this one side is not. So that's 8.69 and that's 10. Let's check this other side here. That's 9.9. Yeah, this side is flat. This side is tilted to one side, which is bugging me. So I'm going to. I can say I've definitely never had it like this before, where the linear rail does not sit flat. I don't know if it's the 2020 or it's the rail, but it does not want to cooperate with me, that's for sure. Okay. Yeah, it's definitely angled downward quite a bit compared to the other side, which is quite flat. I don't know. I don't even know if I can show it on camera. Yeah, you can definitely see how angled downward this is. I mean, it even looks like this one is angled downward, but it's not. That one is quite flat, and it does measure quite flat. But yeah, this side is definitely not good at all. And it's because this rail is actually tilted, which is very annoying. I may end up replacing these rails off stream. Okay, so No, the rails are just not flat on the 2020. They're just really, really, really terrible quality. The 2020 is poor quality, or the rails are poor quality. So I'm going to completely loosen this one side. So now I can hopefully adjust this a bit better so that it's actually flat. I don't know what the heck is wrong with this. Get my square. I think this will fit in here. Yeah, okay. So we can try to square this up as much as absolutely possible. And when you use the actual carriage to try and make this rail flat, okay, so I'm going to try to so you can see how much better the x-axis is moving now that the rail is not twisting sideways, or on an angle I should say, and it's looking much, much straighter. So can we actually bolt this down now so that it's flat? I never spent so much time trying to get linear rails to sit into the 2020 flat. Yeah, it's looking quite a bit better. So we're going to try to lock this in as best as we can. I would hazard a guess that the 2020 is not good. It is perfectly smooth the entire way. If I slide it all the way to the back, it's nice and flat. So let's tighten this front M5 up. Try to just get this all cinched up. All right. Perfect. All right, so that's massively better. So what we're going to do is, I'm missing some parts. So what we can do is we can install the top and do the front idler. So I'm using a M10 spacer, or a 10 millimeter spacer, and then there's a 0.5 millimeter washer, a 1 millimeter washer, and then there's a 0.5 millimeter washer on top of that. Pretty easy. And this is for this side, and our M5 dowel, got hot glue. Our M5 dowel, these are 30 millimeter dowels here. So basically we're just putting this on here, and we are going to go ahead and bolt it down. I don't have the parts for the rear idlers. Hey Zombie, welcome to the SimpleCore Redux, the polished version, thanks to Chaz. So we're going to install these carriages. So I had to order some idlers for the rear, some toothed idlers for the rear, and I had to order some 9 millimeter standoffs. You can print the standoffs, of course, but I prefer to just have aluminum standoffs. Amazon has lots and lots of them in different sizes, so it's very easy to get those. And they work very well. They fit the dowels or the pins really well. So these are just 10 millimeter spacers off of Amazon. So we'll just install these M3. All right. Yeah, so we're all right on movement, and you can see, you can hopefully kind of see the, if I can get this thing to, so you can see the idler stack there on the front. So we're good there. The smooth ones are actually, the ones I have, Chaz, are too short. Most of the smooth idlers, they're 9 millimeters or 8.5. They're not 10 millimeters like the ones that are on the CAD. So that's something that I should say to everyone is be very careful when you're buying idlers, whether it's smooth or toothed idlers. They come in 3 heights, 10, 9, and 8.5. That mellow ones I think are 10, but Pouch has a different size, like they're different heights. So you really got to be careful when you're ordering. And actually, Chaz, that's something that you should put in the bill of materials, is put the height of the idler. because most of the ones on Amazon are 9 or 8.5. I ordered some 10 millimeter like mellow ones from 3D Lab Tech. Hopefully those are going to show up here this week. Those are the correct ones, but yeah, they're all sorts of different heights. So you got to be very, very careful when you're ordering ordering that type of stuff. So, all right, so I have my other Y carriage top for the left-hand side. So basically, we're going to do the reverse of this. Our bearings are on the bottom instead of on the top. So we're going to use our 10 millimeter spacer on the top this time. So I'm going to install the 30 millimeter dowel. And that just fits in there nice. And then we're going to use a 0.5 millimeter shim. Yeah, so I recommend, like, everyone order from the bill of materials if you absolutely can. You're going to have a much better time. So we are doing a 0.5 millimeter shim. And then we are going to add our bearing. Sometimes these F695 bearings can be a little bit tricky to get onto the dowels, but they do fit quite well. And then we are going to be using a 1 millimeter washer in between the bearings. And then we're going to put on another F695. And then we're going to put on another 0.5 millimeter shim here. And then we're going to put on our 10 millimeter dowel. Yeah, they're not loose or anything like that. Some of them though, you got to just wiggle it before it slides on type thing. So then we can press our dowel on into the top here if we can. There we go. So I'm just gonna bolt this in first, and then I will show you the front view a bit better of the printer. Yeah, the Amazon pins, like the 30 millimeter pins on Amazon, work really well. I believe they're Unicell brand. They fit perfectly. They fit the printed holes perfectly, and they fit the bearings perfectly. Everything works out really well. So let's just tighten those guys up. So hopefully you'll be able to see. We have our upper idler right here, bearing stack, F695, and then we have our lower bearing stack right here, F695, and we have 10 millimeter aluminum spacers in here. So everything's at a nice height. Everything's running nice and smooth. You can see that I can move this. This is a very important test. You should be able to move your axes with one finger on the very edge of it. We have no binding. It's nice and smooth. Like it's butter. So that's very, very Very, very easy to move. So yeah, smooth pins are absolutely superior, and honestly, I mean, they're the same price, if not a bit cheaper than M5 bolts. So you might as well. If you don't have M5 bolts, you can go ahead and just put lock nuts on the bottom. That will work, but I highly recommend going with pins. Yeah, this is a Voron carbon tube. So I modified the bottom plates to be able to use this Voron carbon tube. So I have my pins and everything for the back, but I don't have idlers. And I don't have my 9mm tall spacers from Amazon yet. So I'll do the rear idlers at a later time. We can, however, install the rear idler mounts. So what makes SimpleCore so simple is the motors are at the front for a reason. By putting the motors at the front, we don't have any belts in your view. And because of that, we also don't need as many bearings on the back. Where Voron belt path, they have the bearing, or they have the motors on the rear. They need more bearings to actually keep it so there's no belts in the front. So we're essentially getting rid of like around 2 to 4 bearing stacks completely out of the bill of materials by having the motors in the front. Right? SimpleCore is called SimpleCore for a reason. It's the absolute distilled down version as much as possible for Core XY. Right? I eliminated as many bearings as I possibly could that were not necessary. So, and yes, to some people it might look cleaner to not have the motors on the front of the printer, but that's the idea, is to distill this down to its simplest version. The less parts you can use, in my opinion, the better your printer is going to be. So you always want to have the minimum amount of parts possible as far as like motion is concerned. I don't want to keep adding bearings. I don't want to keep changing the belt path every which way and all this kind of stuff. So I'll show you a close-up of the idlers a bit better here in just a moment. So we are going to have to adjust the height of these, of course, once we get our belts ran. I won't be able to do that in this stream just because I don't have all of my idlers, but so we're going to have to tip this on its side. We're just going to slide in some M5 T-nuts here. And again, I am using sensorless homing, but Chaz did include some holes here for an end stop. If you do want to use an end stop, that's totally fine. It's your printer. You can build it however you choose. And I don't want to do this. I want to install the other one first. To actually thread in correctly. And again, we'll have to adjust the height of these. I always use the LDO sensorless homing, Chaz, and it's really, really good because basically it adjusts the motor current, so when it homes, it's much more accurate, and then it backs off the X, and then it homes Y, and then it backs off. if your belts are not under tension when you're homing Y, it's perfect every single time. The key is you got to actually have a homing sequence that actually accommodates sensorless homing. So I always use the LDO V0 one, and it works really, really good. Because it adjusts the motor current, and it also adjusts it so that your X belt is not fully like under tension and locked all the way into one side before it homes Y. That'll give you inconsistent sensorless homing. So I just use their macro on for the LDO V0. Okay, so this is what the bearing stack looks like. It's really simple. It's just 0.5 millimeter washer, bearing, 1 millimeter washer, bearing, 1 millimeter washer, bearing, 1 millimeter washer, bearing, 0.5 millimeter. Your 0.5 millimeter washers goes on the printed sides, so on the top and the bottom. Yeah, and then there's definitely other choices. That's one of the beauties of Clipper is there's so many different ways to do things. And it seems like there's like different, better solutions coming out all the time. So, yes. But if you want just straight simplicity and you don't care about running wires, end stops are the way to go. Just get a couple mechanical end stops, 2 wires per end stop, and you're done. There's no tuning, there's no dialing in, and it's reliable and it works. So. It's nice that this printer can accommodate both. I'll probably have to like make a printed block for sensorless homing because I don't know if it'll hit any printed parts before it actually homes, but that's not a big deal. Yeah, imagining that's what I'll do is I'll just print out a like 10 millimeter, or I'll just use one of my 10 millimeter shims. We'll set the height of them properly once we get our belts. But again, that's the whole rear idlers. On a Trident, you'd have your plates on the back here with a bunch of bearing stacks and all sorts of stuff, and the bearing goes every which way to get it so that there's no belts in the front. SimpleCore gets rid of all that stuff. Again, just my personal choice. I'm not saying that is massively better or anything like that. There's nothing wrong with the Trident, but I just wanted to make a printer that was really easy to build. And you can see my X-axis obviously works perfectly fine. There's no binding or anything like that, but I do need to hold this up so that I can work on it. Doesn't help that this is on an angle. Yeah, I am very excited to get this thing printing. It's been a minute since I've had a SimpleCore. So this will be a great printer if I just want to print something off really quick. I'm not 100% sure if I'm going to enclose it or not. I haven't decided. I definitely have a laser that can cut panels this large. So that's not a big deal for me. So I might end up enclosing this with some black acrylic. And then I have some smoked acrylic for the door. So, hey, welcome, welcome. Yeah, I'm gonna definitely cut out a bottom panel, a black bottom panel, and a black back panel for sure. Absolutely. I'm just not 100% sure on how far I want to go. If I want to do the sides, top, and then do a smoked front. but we'll see. But I am going to definitely cut out a bottom panel. I'm doing things a little bit differently. So I'm going to have my power supply mounted on the bottom panel, but the main board's still going to be on the back. Just shorter cables to get to the back. But I might change my mind. We'll see. All right, so there we go. So homing the Y is really, really easy. We can just basically take it all the way to the back and it will hit the idlers nice and cleanly. When I install my bearings though, they may stick out. So I might have to, like I say, I might have to put some 3D printed blocks for me to sensorless home. But that's not a big deal. That's a really, really easy thing to do later on down the road. Okay, let's install some of the EVA ecosystem and the mods that I have made to make this work. So what I'm going to do here is we have our EVA carriage. I have already printed this out. I have my adapter here. So this is the adapter that I'm going to use to install the AT4 toolhead. The rest of the parts are EVA parts. However, this is a modified, it's a mod on printables to run an MGN9 rail on the top. Again, EVA by default is MGN12. And then this bottom piece here is a smooth ductless piece on printables because we're not running a fan on this. Our fan is going to be on our AT4 toolhead, which we'll talk about in just a little bit. Hey, welcome. Okay, so obviously I need to take this apart before we can install it on the X. So we're going to go ahead and just quickly take this apart. It's 4 pieces, a front, back, top, and bottom. Yeah, I have a stock EVA 3 toolhead on my Defiant cross gantry printer, and the cooling is perfectly fine with the tri-horn duct. It's able to do a 16-minute benchy really easily, a PLA benchy. So the stock EVA is not bad, but yeah, it's not. It hangs over the front quite a bit. I mean, this is going to do the same as well. It's just there's pros and cons to everything. But that's why I'm going Bowden with this to try to... Actually, I don't even really need to take these ones out. So anyways. So this is my prototype AT4 mounting plate. We have some slots on the side to wrap belts around for the front belts. But I think I might change these to apex clips in the future. So... this is not a final version. I might have enough room here to have an apex clip hold the belts in, which would be much more straighter. It'll keep the belts nice and straight versus looping them around and then like zip tying them or sandwiching them together or something like that. I might be able to fit enough room in there for apex clips. This is a 220 by 220 cubed printer. Yeah. Yeah, they're... I don't know about them being too... Well, so Ian, there's one for an end stop and there's one for sensorless homing. So the sensorless homing one is like... the block is the same size. This top block size won't change, but it can stick out for an end stop. The sensorless homing one it doesn't stick out on the sides, but the actual block itself, like in this direction, is always the same size as far as I know. Maybe there are blocks that add some more space, but that would change your belt path. So the blocks on printables should always be the same like width. The length does change though if you're going sensorless or you have an end stop as far as I've seen. So we are going to install the MGN9 modified adapter on the top here. Just want to see if this is M3x6 or M3x8. So it looks like it's definitely not M3x6. It might be 8 or 10. I gotta go check my bolts. I want to say it's going to be 10, but we'll see here. Actually, I'm just going to go straight to 10. Yeah, it is 10. Could probably even do a 12. It was $50 Canadian. I am going Bowden with this, so I am trying to make it as light as absolutely possible. So Bowden, and I'm using an MGN9 rail for X instead. So I'm doing everything I can to make sure that it is light as possible. Oh, the height. So we're gonna make sure this is nice and tight. So there's our top EVA MG9 EVA mount. So this is the EVA back. This also has your belt tensioning in the rear. So we're going to install this in the back. Normally EVA would have the cooling in the back as well, but we're not using that. Yeah, the carbon rod is probably cheaper, especially if you're in the US. There's different versions. There's FISEC makes one, Mello makes one. They are slightly different on how to mount them. So you do need a different part to hold the M5 nuts, depending on if you go FISEC or Mello. SimpleCore uses the EVA tool head. All right, so we have our EVA rear piece put on here. I'll try to put this on the side so people can kind of get a better view of it, possibly. So yeah, here's the EVA backpack, whatever you want to call it. And then we have our Dragon Burner style plate. This is for the AT4 tool head. So I need to make sure that I put this in the right orientation. I'm most likely going to modify this, like I say, to use apex clips instead. And I need to make sure that this is the right way around. We're going to just bolt these together. So I line up the holes. Come on. had this together once. I need to turn this around here. I think I have this on backwards, I think. Let me just take a look at the tool head here really quickly. Yeah, so that goes on like this. I believe, at least. Make sure that I am doing this the right way. Yeah, it is this way, okay. Okay, so let's mount this up. Do I have this the wrong way around? I need to double check something here. So this goes like this. Okay, so that's yeah, it must go like this. Okay, let's see here. One of these pieces sticks up above the plastic part, but I can't remember. Pretty sure it's not that way though. Yeah, okay. I'll turn this a bit more so you can see it. Well, it's kind of obstructed, but you can at least see part of it. So essentially the EVA 3 toolhead is just a box that goes around the 2020 extrusion, or in my case, the carbon fiber tube. So 4 bolts, connects the back, front, top, and bottom. And And there we go. So there's the front view of my table. Is not even close to flat, of course, but that's fine. And then my very slightly modified AT4 will bolt to this. So I can line it up correctly here. I have to take this all apart anyways, so we're just going to we're kind of just mocking it up. So we'll just bolt this on here. So there we go. We have our AT4 tool head mounted. It's just a 4010 cooling with the AT4. Like I say, this is not standard. This is normally your EVA 3 would have its own cooling and solution, all that kind of stuff. I wanted to use AT4, so I am using the AT4 tool head. I did modify this cowl for this printer, but I've only modified the bamboo cowl. This is not, AT4 has a different cowl for every hot end, so I've only modified the Bamboo Labs one because I have bamboo hot ends. So yeah, it's pretty easy. And then I have a Bowden adapter that's going to sit on here, and then my Bowden tube with my extruder somewhere on the back, however I want to do it. So yeah, we should have definitely a good amount of room, and this thing is running very, very smoothly. So I'm very happy with that. I'm also not going direct drive because this is like, this does have some flex to it. It's mostly because the MGN9 on the top here. So there's no weight on top of this, which is what I wanted. I'm gonna make a beacon mount for this bottom piece here. I have my beacon over here. I still gotta order my bed too, which will take a little while, but I have a brand new sealed beacon I've never used here. So I am gonna be just mocking up a beacon mount. The beauty of it, there's a huge flat spot on EVA right here now because there's no, I'm not using their fan. So I have a huge flat spot here for a beacon mount. Because I'm using the AT4 tool head, I have all of this flat area here to have beacon, so it's perfect for that. But this is the first time that I've seen this tool head on the printer, which is really cool. Yeah, so very happy. This is going to have really awesome cooling, 4010 fans here, and they have backflow inhibitors. I have glued them into the fan. I've done one fan already. And I'm using the bamboo hot end, of course. There's a 2510 Delta fan on the front here. And yeah. And I think this will probably work okay for homing as well. This should be able to slide all the way. Yeah, so it does hit the printed part, which is perfect. So I can do sensorless homing really easy. Yeah, I probably should install the motors just to get the full effect. So we do have, although I don't have the I don't have the double shear parts printed out, and I don't have the heat sets installed on the motor pods yet. But the general idea is we're gonna basically have our motors installed like this. I actually probably won't install them because I'm just gonna have to take them back off after stream, but our motors will be installed in the front here. And I do have, these are some nice LDO motors that we're going to be using on X and Y. I've got my pulleys for them and stuff. I already have my 80 tooth Z and all that kind of stuff. So I do need to print out like the actual gearbox mounts and stuff like that, but I've got all the parts. I've got all three of my 80 tooth pulleys printed out. Yeah, I'm gonna just, I probably won't go crazy tension, but I'm gonna still just print it out as intended and build it as intended. So yeah, a single 50-15 fan overvolted works really, really, really well. That's what I have on my stock EVA 3. It's a 12 volt GDS time running on 24 volts, and it's just a tri-horn EVA 3 duct, and it works perfectly. So, but yeah, I'm very, very happy with how this printer is looking and how it's turning out. Everything is nice and smooth. I already have my Bowden adapter made, so I just need to print that out, put some heat sets here, bolt that on. I've got my other fan for this side already. I just need to make a beacon mount and then get my bed, and we should be pretty good. Yeah, this should be pretty good with these GDS time fans for cooling. I'm not going insane speeds. This is an all-purpose printer. It's going to print, it probably will eventually print ABS, but it's going to be a lot of PLA and that type of thing. Mostly PLA and ABS probably. So, but yeah, you can see the XY gantry is very simple to install, very minimal bearings, and it's quite easy to run the belts. There's not like a whole bunch of hoops you have to jump through to feed the belts. You can basically assemble everything and then feed the belts very, very easily. So I do also need to print the skirts out, put my rubber feet on here, and then I'll do a stream just on assembling the Z. We'll get the Z all assembled. I do need to buy my linear rails as well. I'm just going to probably go MGN9 for the Z as well, and kind of go from there. Welcome, Tinker. I think we're going to be wrapping the stream up here. I got to where I want to for this stream. Probably next stream we're going to run the belts. I should have my idlers, and I should have my my 9mm spacers for the rear, and then we can mount the motors, run the belts, all that kind of stuff. I can't remember. I want to say, I need to double check and remember about the MGN or SimpleCore. I think you need to use mirrored belt tensioners for SimpleCore. I can't remember, so I got to figure that out. Yeah, I haven't decided if I want to do 12s or 9s. I guess, yeah, I am doing a bit non-standard. 12, you normally have a 12 for your X, which I have a 9. So 12's very common. I'll have to decide on how I want to do it. I can see my gantry is a little bit twisted, but we'll fix that when we actually tension the belts. But yeah, I don't know if I'm going to do MGN12 or MGN9. So yeah, MGN9, I might just do 12 just to make my life easier and get this thing going as soon as possible kind of thing. So I need to print out the gear boxes, I guess, the mounting parts, and then the top pieces. That should be pretty easy. I might already have tooth idlers for the Z, and go from there. So that'll be pretty easy to do. But yeah, it's looking really good, and the tool head is very, like this whole gantry is super lightweight with this carbon tube, with the MGN9, and I'm not adding weight on top of this, so it's going to be a very lightweight printer. We'll see what the input shaping graph looks like. The only disadvantage with the bamboo hot end is the nozzle. To get a nozzle accelerometer is really, I don't even know if they make one for the bamboo hot end. That is a big disadvantage, is to run a nozzle accelerometer. It's not standard. So maybe I'll have to modify another AT4 tool head in the future to do, but I'm just going to use the input shaping. I'll mount it somewhere over here or something like that. V6 nozzles fit the TZ hot ends. Yeah, I might have to get a TZ extruder because I'm using the factory bamboo extruder. Is YouTubing worth it on the 3D printing niche? You mean to make a YouTube channel? I mean, it depends on what you want to get out of it. Yeah, that's what I was wondering, if it's like Cartographer Probe. It had accelerometer on Beacon too, so yeah, that's probably what I'll use. I couldn't remember if it had an accelerometer on it as well, but yeah, I'm very excited to use Beacon because I ordered this like 6 months ago for Pegasus. But yeah, so we will probably run the X and Y belts next stream, and then I'm going to start working on printing out the Z parts. And honestly, this thing is going to be printing sooner than you think. So that's going to be really, really great. And I really do like how this looks. I should be able to put an LED in the SimpleCore cutout here as well. So yeah, it does. But if I remember SimpleCore before, Chaz, because the teeth are different, like the teeth are not the same, the belt teeth are not the same way. I think you have to, there's a special tensioner version that you have to use. Like the tensioner block will work, the belt lines up properly with the top. The problem is the teeth are facing the wrong direction. So on printables, I'm pretty sure, or on the EVA 2.4 GitHub, there is a mirrored set of blocks for this. If I remember correctly, you can't just use the EVA ones for some reason because the belt teeth go the different direction. So I have to figure that out and try to remember it. But I want to say that EVA 2.4 did have mirrored. It's not even necessarily a mirrored part. It's like the teeth are just a different way and they're spaced differently. But the parts do already exist out there. I just got to find them again. And like I say, that's why I'm doing a printables page. So I can put all these parts in one location and you don't have to dig through like the EVA 2.4 GitHub and all this kind of stuff. But yeah. On the right hand side, the tensioning block is on the top, and on the left hand side it's the bottom. That's fine. I know that works. It's just where the teeth actually enter the block. It's wrong, I'm pretty sure, on SimpleCore. So we need to, but there's an EVA 2.4 block that works, if I remember correctly. I can't remember. But I think it's like M3 instead of M5 or something like that. I gotta remember. It's been like 3 years since I built SimpleCore, because I know that hasn't changed. So, but yeah, I think that's where we're gonna call it for today, guys. I really hope you guys can see how simple this is. Even the number of parts, right? To get the gantry going, there's 1, 2, 3, 4, 5, 6 parts to get the gantry assembled, and then EVA is 1, 2, 3, 4, 5 parts. The amount of printed parts is very, very minimal on SimpleCore. And I think this printer is going to look really nice with this carbon tube as well. As being much more lightweight for this type of design that I'm going with, without running direct drive and all that kind of stuff. I think it's worth it to go with the carbon tube. I'm not going to run a chamber heater or anything like that. I'll just print ABS at like the 40 degrees that this thing gets to, most likely. Maybe I will put like a bed fan or something like that in here to help heat up the inside of the printer a little bit better, but I'm not going for like heated 60 degree chamber temps or anything like that. I just don't print enough ABS for that. But so yeah, that's kind of where I'm going to end it, everyone, for the stream. I appreciate everyone stopping by and hanging out. I was hoping to run the belts today. I really was, but I just didn't have the right idlers. I was hoping they would ship sooner, but I haven't seen my shipping notification for those yet, and I ordered them yesterday, so we'll see how that goes. No chamber heater. I don't need it. It's definitely not going to be used for anything crazy. I just print my good old standard Sparta 3D ABS, and 40C chamber temp is perfectly fine for me. So, but yeah, I'm gonna end the stream there, guys. Appreciate everyone stopping by and watching. And next stream we will be running the belt, so X and Y is gonna be completely done. And I think we can start assembling the Z. I'm pretty sure we'll be able to start assembling that. I actually don't think I need to order any parts for that. I've got some cheapo motors we'll use for Z. It's not a big deal for Z for motor wise. And then I do need to print out just the double shear parts for this to make sure all that works and everything like that. I've already got pulleys for the motors on there. And then, yeah, by like the stream after next, we should be starting to wire, honestly. I might do a little bit of wiring on stream. I'm not too sure. I don't want it to be too tedious, and I would like to get the printer printing soon. But I do have to order my K1 bed. That is something I need to order because I am going with a 110 volt K1 bed instead of the 24 volt standard one. Funsor does make a 110 volt K1 bed upgrade, which I am going to be using. So, but yeah, thanks everyone for watching. Thanks for checking out SimpleCore, and I will catch you all on the next stream.